Right, this video is going to solve the following quadratic equations using the method of factorising. Right at the end, I'll look at the last two questions using splitting the terms, which is not my favourite method, but just in case some of you like to use that. All right, here we go. Okay, there's straightforward steps to factorising something pretty quickly. First and foremost, we just follow our process. So first thing, let's get everything on one side. We then pull out our common factor. Okay, we recognise, or look, is it difference of two squares? If it is, then we factorise it accordingly. If it's not, do we check if it's a perfect square? Again, if it is, we factorise it accordingly. And if it's neither of those, then we go on and we try and do the whole sum and product stuff, okay? So let's give this a go. Firstly, let's get everything on one side because it's clearly not. So everything goes on the left. 4x cubed minus 24x squared minus 64x. Is there a common factor? Clearly there is. Now make sure you pick the highest common factor possible. So x clearly goes into everything. They're all even numbers, so 2 definitely does, but always check, does 4? And in this case, 4 does go in. So you're either asking yourself 4x times what gives you everything in this line, or you're just dividing everything through by 4x. Okay, so we end up with 4x times x squared is x cubed. 4 sixes gives me 24, and I've got to have the x there. And 4 times, what have we got there, 16, gives me 64. Just double check that, that's correct, equals 0. So now we keep that 4x out the front, and now we're going to do our sum and product. So we look at this 16. Are there two numbers that times together give you 16? Negative thereof, but add up to be minus 6. Now, you probably already know it, but just in case you don't, we've got 1 and 16. List them automatically. I'm not just going randomly. 1 and 16, then 2 and 8. Does 3 go in? No. Does 4 go in? 4 times. 5, no. 6, no. 7, 8. And I've already got 8 in there, so I know I've got all of those factors. And we can see that it's that pair there is the only way that we can get a 6. And to get negative 6, it must be minus 8 plus 2. Okay, always double check. you're factorising by expanding. So x times x, yes, I get the x squared. X times 2 is a plus 2, but then I have to take 8. So yes, I get the minus 6x, and a negative 8 times positive 2 does indeed give me minus 16. So I know that works. You've done all the hard work. Make sure you finish that off by solving. Now, because it's an x cubed, we are expecting there to be at least 3 solutions. So what are they? Well, what values for x make this whole thing equal to 0? Well, when x is 0 right at the beginning, 0 times anything is 0. In this next factor here, if x is 8, 8 take 0. Sorry, 8 take 8 is 0. And of course, with the last factor, if x is minus 2 plus 2 gives you 0. So we've got all of our factors there. And it's zeros. All right, let's have a look at the next one. So you might be tempted to expand this first one, but remember, always go through your process, okay? Yes, it's all equal to 0. Is there a common factor? So remember, common factors could be not just a letter or a number, but can you see I've actually got a whole factor here that's common. So I'm going to pull that common factor out. So it's going to be x plus 6. Now when I remove that, I'm left with the x minus 2. And when I remove this, I'm left with the minus 2 x plus 4. Now just a warning that if you happen to have an expression that doesn't have this 2 here or in any other number, make sure you still include this bracket, okay? Because when there's a minus, the bracket makes a massive difference. So do make sure you keep including that. All right, so we keep our x plus 6 here, and we are going to just tidy up what is inside our second bracket. So expand that one, 2x take 8. Keep going. I've just gathered my like terms in the second bracket there. Now you're pretty much done, but that does look a little bit awful. So are you aware? Minus x plus 10. So I've basically pulled out minus 1 here. So imagine if I expand this, minus 1 times x gives me minus x, and minus 1 times 10 gives me minus 10. So that is actually the same as minus x take 10. And it looks a bit nicer. So I'm actually going to rewrite that. The minus x plus 10 can go out the front. X plus 6. And there we're fully factorized, and now I can solve and say x is minus 10, or x could be minus 6. Right, next one. Oops, we don't want that. So again, we look, everything is on one side, check. Back to our list. There were no common factors, so does it look like this? A squared minus b squared. And I would say yes, it does. Okay, so this is what we call difference of two squares. And we factorize this to be like that. And basically, we're taking the square root. Okay, so what times itself here gives me the a squared. So this is going to be a typical square root of, so x times x gives me x squared, and what times itself gives you 25? Well, it's minus 5 and plus 5, and that is difference of two squares. Nice and simple. I can write it as equals 5 or minus 5, or I can do the shortcut plus or minus. Okay, so next one. Everything's on one side, all is well. Is there a common factor? No, it looks a bit hideous, but again, I would argue this looks like a squared minus b squared. So what times itself gives me 16x squared? Well, I've got 4x times 4x. And what times itself gives you 91? Well, that's a typo. I think I meant to write 81, but that's good in effect because you can just say, if it doesn't have a nice square root, you can just put minus root 91 plus root 91 equals 0. And we're solving each one of these brackets has to equal 0, right? So 4x take root 91 equals 0, and we just pop that root 91 on the other side, get rid of the times 4, you divide by 4. So that's why we can confidently say that it could be root 91 over 4, and of course we could have plus or minus from each bracket. Carrying on. Okay, all right, well, again, another option is you could expand, then you get everything you'd have to factorize. But I'm looking at this, and once again, I can see something squared minus something else squared. So I'm going to factorize this using difference of two squares. So what times itself gives me x take 4 all squared? Well, x take 4 times x take 4. And what times itself gives me 9x squared? Well, that will be minus 3x and then plus 3x. So this is a lot easier to do if you can recognize difference of two squares. If you don't, you're still expanding and gathering your like terms, and then you've got a little bit of a hideous expression to factorize. All right, let's tidy up. What's x? Take 3x. That's going to be minus 4x. Take 4. And then we've got the next one to simplify. X plus 3. 1x plus 3x is 4x, and then we've got take 4. Now most of these questions will say fully factorize. So if I look at each one of these brackets, these factors, you can see that each one has a common factor. Now the first one has a common factor of negative 4. If I pull that out, negative 4 times x gives me negative 4, and negative 4 times positive 4. Oops, better not say positive 4. Positive 1. All right, and that's why you always double check if you expand, do you get what you have up there? And then you've got this next factor, 4, x take 1 equals 0. And so really out the front, I can multiply these 4's together, so it's minus 16, x plus 1, x take 1. And so therefore, x can be plus or minus 1. Right, let's have a look at the next one. All right, everything's on one side. There is no common factor, so this is your typical. Let's look at the 48. We want two numbers that times together give me 48, but when I add them together, I get negative 14. The fact that it's minus is telling me both values have to be negative, because two negatives times together give you a positive number here. Love 48 because it's got so many factors. Those people who are good with multiplication, their times tables, probably already know what the answers are, but if you're not, we list them. 2 goes in 24 times. Does 3 go in? Yes, 16 times. Does 4? Yes, 12 times. 5, no. 6 goes in 8 times. 7, no. 8, you've got them all. So which pair could I get 14 from? It's these guys. Okay, so x minus 6, x minus 8 equals 0, x equals 6, or x equals 8. Now, at this point, we want to remind you that you can also check this if you've got the calculator. If the question asks you to fully factorize, then we just go in here, equation, polynomial, degree 2, and you pop in 1, negative 14, 48. It actually gives you those answers, so you can work backwards and say, well, if the solutions are 8, that means x take 8 is a factor, and if the solution is 6, then x take 6. Okay, all right, let's have a look at this one. Everything's on one side. Right, we're hoping for a common factor of 5, but alas, there isn't. And remember, we're under the impression that these questions are all saying fully factorized, because if it didn't, then you basically go straight to your calculator. If it said in algebraic mode, yes, try factorizing or quad form. All right, so we're looking there. We look at this number here again at sum and product. So we're looking at the factors of 3, so it's only 1 and 3. But we want to get 14 here. So it has to be the case, right? It has to be 5 times 3, because 5 3s will give you 15x. Close to 14, so that's going to be the positive, and then we're going to take away the 1. And that, my friends, is fully factorized. Right, so how do I now solve? Remember, you're solving 5x take 1 equals 0, so the 1 goes on the other side, and you have to get rid of that times 5, so you divide, so 1/5. And then we've got x equals minus 3. Now this was pretty easy because our last number was a prime number, so we didn't have to fool around too much. Obviously, if our number here is not prime, it makes it a little bit more annoying, and it's the most annoying if even this value here has got several factors. Anyway, let's have a look at this one. So the only way that we can get 3x squared is to say 3x times x. And now we're looking at the factors of 12. So we've got 1 and 12, we've got 2 and 6, and we've got 3 and 4. Now I'm ruling out 1 and 12 straight away because it's not going to happen to get me the 5 there, because if you put the 12 here or the 1, right, I'm going to get a 36, and a 1, there's no way I can get the 5. And similarly, if I put the 12 here and vice versa, right? I'm also ruling out 2 and 6 because they're both even, and I want to end up with an odd number. So that's out. So now I'm left with 3 4s. And again, this is where your times tables and your understanding of expanding should help, because we can see that 3 times 3 gives you 9x, and 9x take 4x, we'll get 5. Now we want minus 5, so that means it's got to be minus 9x and plus 4. And expand, that can help you. Okay, again, if you got stuck and you had your graphics calculator on you, your calculator will give you, right, these values. So your calculator would give you x equals 3 is a solution. So you know automatically that x take 3 is a factor. So then you're saying, well, x times what gives me 3x squared? It has to be 3x, and minus 3 times positive 4 gives you that. So, you know, technology is there to help you out. Splitting the terms. So you can sign off now if you're happy with that. And, you know, you're doing a couple of times, you must go and practice. You've got to do as many of these as you possibly can and practice your multiplication, okay? Now, splitting the terms. Okay, what we do here is we look at our 3x squared, take 5x, take 12, and we say, what, 3 12s? We better put the minus in there, I guess, is minus 36. So we're looking for two numbers that times together gives you minus 36, but when you add them together, you get minus 5. So got to know your factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, bingo, bingo, bob. All right, and we want minus, so it's going to be minus 9x plus 4x. So this now becomes 3x squared, take 9x, plus 4x, take 12. And we split this up now. So we're splitting and we're splitting. And it wouldn't matter if you had written 3x squared plus 4x minus 9x, take 12. You would split and split. You'll see what happens. So with each split, we look for a common factor. We can see in that first one, it's 3x, x minus 3, plus 4. Oh, look at that. X take 3 again. What a surprise. So now we pull out our x take 3 as a common factor, and we're left with 3x plus 4. Huzzah! That's what we got up here. You're asking what happens if you didn't do it in that order? Well, let's look over here. What's my common factor? Here it's x, so I pull out x and look at that, 3x plus 4. What's my common factor here? It'll be minus 3, and wouldn't you know it, you get 3x plus 4. So you can pop that out as your common factor, and you get the same expression, okay? not a fan of splitting the terms. It is nice, it's cute, but I like to just factorize straight out. Hopefully that helps.